Hello, Honors Algebra 2. In this video lesson, we will be introducing probability. The odds, the likelihood, the chances of something happening. These are terms that you've probably heard in the news or the media, and maybe in math classes in elementary or middle school. When it comes to probability, it's nice to think of it in terms of a scale, going from the impossible to the guaranteed, and somewhere in the middle being something that's 50-50, like flipping a coin and getting a heads or a tails. Many events, however, don't fall into the clearly black and white, impossible, certain 50-50. There's lots of variations in between. So with probability comes set notation, which we've seen before. So this idea, this upside down U here, is the intersection, the overlapping part of two sets. The U-looking figure is the union. If you look at this picture, a union would be all of it, the part they share and the part that they have separately. A prime represents the complement, so something that isn't A. This x/y that you see here, this means like a relative complement. So the odds of something in terms of something else. You'll see that more in the next video lesson. And then this 0 with a slash through it is called the null set, or sometimes you'll see it with just two brackets that are empty in between. It just means an empty set, a set with no values. So let's talk about types of probability. Theoretical, sometimes called empirical, is based on every odd being equally likely. This is kind of that, what's your prior knowledge, what's your common sense level? So like rolling a 2 on a normal dice, well, that's a 1 out of 6 odds. Or drawing a 9 in a deck of cards, it's 4 out of 52. This is what should happen. Experimental probability is based on results of an experiment, a survey, maybe just looking at back the history of something, or a trial that was run for medical research. These are experimental probabilities. So with cards and dice, these are all the different cards in a standard deck, and these are all the combinations of dice you could get if you roll 2 at the same time. This isn't much for me to say as far as math goes, except that most textbooks assume that this is in your prior knowledge realm. So if you don't know how many cards are in a deck, or how many suits, or how many kings, this might be something that you use as reference. I would even encourage you to play a few games with your family. Get out a deck of cards, play some Yahtzee, get used to the different combinations that may occur when you're looking through a deck or you're rolling a couple die. So let's say you draw a card from a standard deck. So the odds of drawing a face card. Well, each deck has a king, a queen, and a jack in each suit. So there's 3 cards, king, queen, jack, in each suit. So that means there's 12 face cards out of 52. Sometimes you'll see it left, sometimes you'll see it reduced, sometimes you'll see it rewritten as a fraction or a decimal. What's the probability that the card is either a club or a spade? Well, in a deck of cards, there's 52 cards and there's 4 suits. So when we divide by 4, we get 13. So each suit has 13 cards, and clubs are one of the suits and spades are another one of the suits. So the odds of getting one or the other is 26 out of 52, or 1/2. This time, let's just roll 1 dice. You'll see die or dice. Die is technically the singular, but in America we've kind of transitioned and we say dice is 1 also. So anyways, if we want to find the probability of rolling a 4, we know there's 1 4 on this dice out of 6 possible sides. odd numbers, you have 1, 3, and 5. So there's a 3 out of 6 or a 1/2 chance. Rolling a number less than 7. Well, every number on a standard die is less than 7, so that's a 6 out of 6 or a 100% chance. Let's say 30 students in an Algebra 2 class took a test. 8 got A's, 13 got B's, and 9 got C's. If a student from the class is randomly chosen, what is the probability that the student received a C on the test? So to figure this out, the first thing we need to do is find the total number of students. Well, I told us there's 30, but if they didn't tell us, you could easily add the 3 subgroups. So C on the test, well, there's 9 kids, 30 students, 9 of which got C's, so 9 out of 30, which you could easily reduce and you'd say, oh, 3/10. What about an A or a B on that same test? Well, if you add 8 with 13, you get 21, so 21 out of 30 or 7/10. Some other terms that you might see in this section are complement, which we mentioned earlier with the Venn diagrams, is everything that's not in a set. So if you know something has a 25% chance of happening, it has a 75% chance of not happening. We just take the set A probability and subtract it from 1. The equation you see here is really nice to go back to when you have a more wordy problem with multiple layers or elements that may not be so commonsensical. So this just says the odds of one thing or another thing happening is the odds of the first thing happening plus the odds of the second thing happening minus any overlapping events that might include both categories. You don't want to count those twice. If there's no intersection between two events, they're called mutually exclusive. So what that means is when you're using this equation, you'd just be subtracting 0 because there is no overlap. So let's say a card is randomly drawn from a standard deck of playing cards. The odds that it's not a king. Well, there's 4 kings in the deck, and there's 52 cards in the deck. 52 minus 4 is 48. So the odds of it not being a king are 52 out of 48. Not being a face card. Well, there's 12 face cards. So 52 minus 12 is 40. So odds of it not being a face card are 40 out of 52. The odds that it's not less than or equal to 4. So this gets a little different because I guess it depends whether or not you want to consider ace as less than or equal to 4. Typically, that's how we order them, but that's not always the case. If you do consider it less than, you'd have an ace, a 2, a 3, or a 4 equal. 4 times 4 is 16, and 52 minus 16 is 36. So 36 out of 52 cards are going to be not less than or equal to 4, if ace is considered a 1. Let's go back to the dice. If I roll a dice, what's the probability that that dice is a 4 or a prime number? Well, let's think about this. There's a 1 out of 6 chance that it's a 4. Prime numbers would be 2, 3, 5. And 4 isn't a prime number, so there isn't any overlap, so you don't have to subtract. So 4 out of 6 are 2/3. What's the probability that this number that you've rolled is either an even number or a prime number? Well, 3 of the 6 are even, and 3 of the 6 are prime, but one of them, the number 2, is both prime and even. So you get 5, 6. What is the probability that that number that you've rolled is an even or a 1? Okay, so the odds of it being even are 3 out of 6. The odds of it being a 1 are 1 out of 6, and there's no overlap. So we have 4 out of 6 again, or 2/3. the probability that it's a 6 or a number less than 3? 1 out of 6 that it's 6, 2 out of 6 that's less than 3, and there's no overlap. Probability that it's even or a number greater than 5? Well, 3 out of 6 are even. 1 out of 6 is greater than 5, but that 6 is being double counted. So the odds are 3/6 or 1/2. What's the probability that that number that you've rolled is odd or a number divisible by 3? So 3 out of 6 are odd. Numbers divisible by 3 are 3 and 6. Oh, wait, but that 3 is both. So you need to be smart about subtracting that away. So 4/6. A weather forecast says that the probability it will rain on Monday or Tuesday is 40%. So that's your or. The probability that it will rain on Monday is 30. The probability that it will rain on Tuesday is 60. What's the probability that it rains at both? Now we're doing equation work. So what we're really saying is 90% minus what gives you 40%? 50%. So the odds it's going to rain both days are 50-50. Things aren't looking good for going outside. This last example, in a poll of high school juniors, 6 of 15 took a French class, 11 out of 15 took a math class, and 14 out of the 15 took math or French. What's the probability that they took both? So we're going to that same equation work. We're saying 14 out of 15 took one or the other. 16 out of 15 took French. 11 out of 15 took math. How many took both? 17. 17/5 minus what is 14/5? 15, sorry. 17/15 minus what equals 14/15? 3/15. I hope this gives you a little background before you get into the cons. Some of them are a little more difficult, and so you may want to watch those individual videos as you go, but I didn't assign any of them specifically because the bulk of the topics were covered in this one video. As always, please contact me if you need any help with any of the work that you have assigned this week.